Good morning. We earlier studied the properties of set and different types of set and so on. Now we start a new lesson, relation and function. In this chapter, we study the different relations such as son of, father of, mother of, subset of, connected with the two sets. Consider set A equal to element P and S. P stands for and S stands for shirt. And another set B equal to white, red, black. Then we consider a pair. Pair means first we consider take a band and color it select as white, and we consider band white. That's a pair, simple pair. That is simple pair. The first entry is coming from the set A and the second entry is coming from the set B. Then another possibility is pant black. Pant black. Again, one more. Yes, shirt, red. These are the pairs. Generally, we take the first entry from A and the second entry from B. Then we say it is an ordered pair. It is an ordered pair. Then we can consider remaining ordered pairs connection with A and B. Then here we will write a 3 pair. Then we can write a 3 more pair. That is pant red, again shirt white, again shirt black. These are the possible ordered pairs. In the ordered pairs, we can treat as a human being. Simple example, 2, 3 is an ordered pair. Here we use a simple bracket, and again the first entry is 2. Generally we treat as the left eye, and the second entry is 3. Then we say that is the right eye, and center there is a nose. Then we can convert it as a human being. The ordered pair means a simple human being. The first entry is left eye, and the second entry is right eye, and separated by commas. Again, we consider another set A, that is a set of boys. A particular class contains 3 boys, B1, B2 and B3. There are 3 boys. And the second class B contains girls, G1 and G2. In a certain class, we assume there are 5 students, 3 boys and 2 girls. Then we assume now we consider a pair. The property is that is a girl's classmate. Then B1 classmate is one classmate is G1. Therefore B1 G1. The another classmate of B1 is G2. In the case of B2, his classmates are B2 G1 and B2 G2. Again, B3, G1 and B3, G2. There are 6 pairs. Set of all these pairs is known as Cartesian product of A and B. Cartesian product of A and B. That is A cross assembly, Cartesian product A cross B. That means that is a set of all ordered pairs. Set of all ordered pairs in which first entry is coming from the first set and the second entry is coming from the second set. Elements. An ordered pair of elements taken from any set P and Q is a pair of elements written in small brackets and grouped together in a particular order likewise. This leads to the following definition. So we define Cartesian product. Given 2 non-empty sets P and Q, the Cartesian product P cross Q is a set of all ordered pairs of elements P and Q. That is P cross Q equal to set of ordered pair PQ such that P belongs to capital P and a small q belongs to capital Q. Then one property is if any one of P or Q is a null set, then P cross Q will also null set. That is, any one of the set B or Q or any one of the set A or B is null set, then A cross B is also a null set. Then another point, we consider an ordered by xy is equal to an ordered by 2, 3. That means two ordered by we consider. First ordered by is xy, the second ordered by is 2, 3. If they are equal, then first entry is always equal to second entry. The first entry of the second set ordered pair, and the second entry is always equal to second entry of the second pair. That is, two ordered pair are equal if and only corresponding first elements are equal and the second elements are also equal. Simply an example we can consider: x minus 2 ordered as x minus 2 and y plus 1 equal to ordered by 3. Then x minus 2 equal to 5 and y plus 1 equal to 3, which implies x equal to 5 plus 2 equal to 7 and y equal to 3 minus 1 equal to 2. We can equate to ordered pair. First is xy and the second is 2, 3. The first entry is mostly equal to the first entry of the second pair, and x equal to 2 and y is equal to 3 and so on. Again, another concept. If A equal to set 2, 3 and B equal to set 4, 5, 6. Number of elements or cardinal number of set A is equal to, there are two elements 2 and 3, that is number of elements in A equal to 2. Here similarly number of elements in B is equal to 1, 2, 3, that is equal to 3. Then we define A cross B. Different elements in A cross B are set ordered pair 2, 4, 2, 5, 2, 7, 3, 4, 3, 5 and 3, 7. There are 1, 2, 3, 4, 5, 6 elements. So we say number of elements in A cross B is equal to 6. That 6 is coming from, that is equal to number of elements in A into number of elements in B. Here also, our previous example, A equal to set B1, B2, B3, there are 3 boys, and B equal to G1, G2, there are 2 girls. So, number of elements in A equal to 3, number of elements in B equal to 2. So, number of elements in A cross B, there are 6 elements, that also 3 into 2. Generally, there is a formula: number of elements in A cross B equal to number of elements in A into number of elements in B. Again, we define another B cross L. Cartesian product of B and A, B cross A, that is equal to set ordered pair PQ such that P belongs to B and Q belongs to A. In similar case, number of elements in B cross A, that also equal to number of elements in B into number of elements in A. Then we consider R cross R, where R is a real number. R is a real number, then R cross R is set of all points in a Cartesian plane. That is R cross R equal to set of ordered by xy such that x belongs to real number, y belongs to real number, which represent the coordinate of all points in a two-dimensional geometry. And also we define another R cross R. That's a set of all triplet x, y, z, where such that x, y, z belongs to set of real numbers. Set of triplet, that is R cross R represent set of all points in our three-dimensional geometry, in our space. All the points in our space. Then we consider another point also, that is number of elements in A cross B cross C, that is equal to number of elements in A plus A into number of elements in B into number of elements in C. Then we can do some problems. Our first problem is, if ordered pair x by 3 plus 1 y minus 2 by 3 equal to ordered pair 5 by 3 and 5 by 3 1 by 3. Find the values of x and y. Here we can equate x by 3 plus 1 y minus 2 by 3 that is equal to 5 by 3 and 1 by 3. Our problem is first ordered pair x by 3 plus 1 y minus 2 by 3 equal to the second ordered pair 5 by 3 and 1 by 3. Two ordered pairs are equal. The first entry is equal to, that is x by 3 plus 1 is equal to first entry of the second ordered pair, that is equal to 5 by 3. We can equate. Again, second entry y minus 2 by 3 we can equate as second entry of the second ordered pair, that is equal to 1 by 3. Then we can solve for x. First we replace 1 to right side, that is x by 3 plus x by 3 equal to 5 by 3 minus 1, that is equal to 2 by 3. Again x is equal to, we can cancel 2 by 3 into 3, that is equal to 2. Similarly, y minus 2 by 3 equal to 1 by 3, y equal to 1 by 3 plus 2 by 3, that is equal to 3 by 3, that is equal to 1. That is two ordered pair x by 3 plus 1 y minus 2 by 3 equal to 5 by 3 and 1 by 3. We can solve for x, where x equal to 2 and y is equal to 1. Then we move to our next problem. Our second problem, the set A has 3 elements and the set B is equal to set 3, 4, 5. Then find number of elements in A cross B. For finding number of elements in A cross B, first we find the number of elements in A. It is given as 3. And also the second set containing the elements 3, 4 and 5. So it has also 3 elements. So A cross B contain number of elements into A into number of elements into B elements, that is 3 into 3. There are 9 elements in A cross B. That's the answer of the second question. Then again, our third question, if G equal to set 7, 8 and H equal to set 5, 4, 2, find G cross H and H cross G. G equal to set 7, 8, H equal to 5, 4, 2, then G cross H equal to set of ordered pair 7, 5, the first entry, and here also first entry. Then second element is 7, 4, then 7, 2. Again 8, 5, 8, 4 and 8, 2. This is G cross H. There are 2 elements in G and 3 elements in H. Therefore G cross H contain 2 into 3, that is there are 6 elements. Similarly, H cross G equal to set of ordered pair. First term is coming from H, that is 5, 7 and 5, 8, 4, 7 and 4, 8. Again 2, 7, 2, 8. That is H cross G. Then another way we say the G cross G in our roster form. Then we can convert it as set builder form or rule method, that is G cross H equal to set of all elements X, Y such that X belongs to G and Y belongs to H. That is the Cartesian product of G and H. Sometimes we can represent in the roster form, that is list all the ordered pairs and enclose them in set mode of brackets separated by commas. Then G cross H, the Cartesian product of G and H can be written in the rule method, that is set of ordered by X, Y such that X belongs to G and Y belongs to H. Then another way of representing ordered by 5, 7, ordered by 7, 4 and ordered by 7, 2. Again ordered by 8, 5 O divided by 84, the O divided by 82. There are three ways representing a Cartesian product. The first is the roster form, second is the set builder form, and the third is our arrow notation or the graphical representation of the Cartesian product. Again, then another question. If A equal to set minus 1 plus 1, then we have to find A cross A. And the problem is, if A equal to set minus 1 plus 1, we have to find A cross A. There are two methods for finding A cross A. One is directly we can find. The second method, first we find A cross A, that is set minus 1 plus 1 cross set minus 1 plus 1. That is, our ordered pairs are minus 1, 1 minus 1, 1 minus 1, and then 1. Then we can find A cross A. The first element is in A cross A, first element is minus 1. Then the first element of A is also minus 1. So different elements are minus 1. When we take the first elements from A is also minus 1. That is the first element. The second element minus 1. Then again 1. Then third element is minus 1. Then fourth element is minus 1. Fifth element is 1 minus 1 minus 1 minus 1 again 1 minus 1 again 1 minus 1, the last 1. Number of elements in A cross A equal to 1, 2, 3, 4, 5, 6, 7, 8. That is, number of elements A cross A, that is equal to number of elements in A into number of elements in A into number of elements in A, that is 2 into 2. There are 8 elements. We can find A cross A. Then another problem, given A cross B equal to set ordered pair AX AY BX BY. Find A and B. Here A equal to set of all first entries. Here the first entries are A. So write the set A, B or B. Therefore A equals set AB. And B equal to set of all second entries. X, Y, again X, again Y. So here A equal to set AB and B equal to set XY. That is, first set is given by we collect all the first entries in the ordered pair. Then second set is given by we collect all the second entries of the ordered pair. Another question number 4 is state whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. First question is, if P equal to set Mn and Q equal to set Nm, then P cross Q equal to the given as ordered by Mn and ordered by Nm. Then one way of thinking, P has 2 elements and Q has 2 elements, so by P cross Q has 2 into 2, 4 elements. But here P cross Q have only 2 elements, so our statement is false. Then another reason is, then the element in P is M, the element in Q is also M. There is no M element in P cross Q. The statement is simply wrong. The second statement, if A and B are non-empty set, then A cross B is non-empty set of ordered pair XY such that X belongs to A and Y belongs to B. If A, B are non-empty set, then A cross B is also non-empty. If any one of them is empty, then A cross B is also empty. The second statement is correct. Then third statement, if A equals set to 1, 2, B equals set to 3, 4, then A cross B intersection null set. Here B intersection null set is a null set. So A cross a null set is also a null set. That statement is also true. Then we move our question number 7. Seventh question is, let A equals set to 1, 2, B equals set to 1, 2, 3, 4, and C is equal to 5, 6, and D equal to 5, 6, 7, 8. Verify that first what is A cross B intersection C is equal to A cross B intersection A cross C. That's the first part. A cross B intersection C. First we find B cross C. B intersection C equal to, here B is the set 1, 2, 3, 4, and C is the set 5, 6. Then B intersection C means set a common element in B and C. In B, only 1, 2, 3, 4, and C contains 5 and 6. There is no common element, so B intersection C is a null set. So A cross B intersection C, that also A cross a null set, that is equal to null set. The second part, or right side, first we find A cross B. A cross B equal to set ordered pair A cross B, that is ordered pair 1, 1, 1, 2, 1, 3, 1, 4. Again, here A cross B equal to set 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, and A cross B equal to A cross C equal to set ordered pair 1, 5, 1, 6, 2, 5, and 2, 6. Then A cross B intersection A cross C equal to, intersection means set of common elements. Then here also no common elements. Then 1, 1 here, but here is no 1, 1, 1, 2, no 1, 2, 1, 3, no 1, 3, 1, 4, no 1, 4, 2, 1, no 2, 1, 2, 2, no 2, 2. Then 2, 3, 2, 4 are also not in A cross C. That also null set. That is, that you have to verify A cross B intersection C equal to A cross B intersection A cross C. Second one, we have to verify A cross B. A cross C is a subset of B cross D. A cross C is a subset of B cross D. First we find A cross C. A cross C equal to set ordered pair 1, 5, 1, 6, 2, 5, 2, 6. Then B cross D equal to set ordered pair. B is set to 1, 2, 3, 4. D equal to 5, 6, 7, 8. That is 1, 5, 1, 6, 1, 7, 1, 8. 2, 5, 2, 6, 2, 7, and 2, 8. 3, 5, 3, 6, 3, 7, 3, 8. 4, 1, 4, 5, 4, 6, 4, 7, and 4, 8. That is B cross D. Again we can say every element of A cross C. Every element of A cross C, that is 1, 5 here, here also 1, 5. 1, 6 here 1, 6. 2, 5 present here, and 2, 6 that also present in B cross D. That is every element in A cross C is a member in B cross D. So we can say A cross C is a subset of B cross D. Today we can conclude our class. Then some do as a homework. Exercise number 2.1, question numbers 8 and 9. Okay, thank you.